So in the last lesson, we discussed what central angles were and inscribed angles. Remember, central angles are the angles where the vertex lays on the center of the circle. And an inscribed angle is when the vertex of the angle lays on the edge of the circle. So we're going to take a look and see how they relate as to the arcs opposite of them. So the first thing we want to take a look at, probably the easiest of everything we'll do today, but anytime we have a central angle like we have here, the central angle is always equal to the arc of the sides that it touches. So in this particular one, it tells us that the arc measurement, F to H, has a measure of 82 degrees, which means the central angle, FGH, is also equal to 82 degrees. So the central angle is equal to the arc in which it creates. Now when we have an inscribed angle like we have here, in this inscribed angle, it says that the arc measurement is 82 degrees. And then we have the inscribed angle, we could really call this just H because it's the only one we have, but from G to H to E is the angle we're looking at. And the relationship that we have on an inscribed angle, the inscribed angle is half of the arc mark, of the arc that it touches. So the angle is equal to half. Whatever angle H in this case, times 1/2 is equal to the arc that it creates. So since our arc is 82 degrees, if our arc is 82 degrees, half of that amount would be the angle measurement, 41 degrees. And it doesn't matter where we move this point. If I were to put the point over here and I were to connect these two spots, you're going to see that it's still a 41-degree angle. Anywhere that I put it on that arc, as long as it's touching, or anywhere I put it on the edge of the circle, as long as it's touching the same arc, those secant lines, then it's going to be half. So we can take the arc mark and determine the angle, but we can also take the angle measurement. In this case, it says that NRQ is equal to 30 degrees. And we are asked to find the arc length of NQ. Well, if it's a 2-to-1 ratio, then if the angle is 30 degrees, the arc is going to be 2 times that. So our arc NQ is equal to 60 degrees. And just like on the last one, wherever I move this 30 degrees, if I put it here, connects those, it's still going to create a 30 degree angle. So let's take a look at a few that require a little bit of processing. Here we can see that we're only given angle H to J to K. So this is a central angle with an angle measurement of 120 degrees, which means the arc measurement created by the secant lines is also 112 degrees. And then we take a look and see, well, we have an inscribed angle, angle L here, and as we follow the secant lines that create this, it touches arc H to K, which is the same amount as the central angle, but remember, the inscribed angle is not equal to, but half of this measurement. So what we would have is a 56-degree angle for HLK. Here's another example. My suggestion to you, get out a piece of paper, mark and see where these are. A lot of times these are very confusing on what we're looking for, but the first thing I want to do anytime I have these is to label what they are giving me. Well, they're telling me from R to U to T is an angle that has a measurement of 66 degrees. And they're asking me for angle measurement R to S to T. So let's take a look first of all at the arc measurement for our RUT, excuse me. RUT creates this arc mark right here. But since this is an inscribed angle, not a central angle, since this angle measurement is 66 degrees, that means this arc length is going to be twice that. So we take 66 times 2, should be 132. So we have an arc mark of 132 degrees. Well, this arc from R to T is not only the arc that's connected to our inscribed angle, but is also the arc that is associated with our central angle. But remember, the relationship between a central angle and the arc is the fact that these two angles are, the angle and the arc are equal to one another. So if it's 130 degrees, so is the central angle. And that's what our answer would be here, 132 degrees. So as usual, we have to work on these as algebraic expressions as well. Numbers are nice and fine and good. It's great if you understand those, but we've also got to be able to do algebra. So as we read, it says circle H, arc GI has a measure of 100 degrees. So this is 100 degrees. So how you approach this is kind of up to you. We could go and set up a formula that's equal to half, or we could just come down here right now and say, okay, if that's 100 degrees, then this is 50 degrees. It really does not matter how you do this process. But what we next learn is from G to F to I has a measure of 12x minus 46. So as we set this up, one thing that works out really well is, well, we knew that this is 50 degrees, so we would set up this formula this way. You also could have said 2 times angle GFI, excuse me, would be equal to 100. But again, this is one of those processes where it would not be wise to distribute the 2 when you could actually divide by 2 and then save yourself some time, and you're working with much easier numbers. So there's a couple of processes that you can use to do this, but we're going to go ahead and do the one that we have right in front of us. So once I've set my values here, I'm going to move the 46 over to join the 50, which has a measure of 96, equal to 12x. Next thing we will do is divide by 12, and we learn that x is equal to 8. As always, we need to go back and read our instructions, make sure we actually answer the question that was asked. And it says for circle H, GI is 100 degrees, solve for x. So we did solve for x, and x is equal to 8. The last example we're going to take a look at for the day, we see that CDE is 113 degrees. Go ahead and mark anything that you know. And it tells me that arc CE has a measurement of 4x minus 21. So unlike the last one we had an inscribed angle and there's the 2-to-1 ratio. This is a central angle. So central angles are just equal to the arcs in which they touch. So if that arc length is 113, we have to set it equal to 4x minus 21. Then it's just a two-step equation. We're going to add 21 to both sides. This gives me 134 equals 4x. We then divide both sides by 4. And we learn that x is equal to 33.5. So we set up our equation and we solve from there. And that's what we should have. You guys have your Delta Math assignment. Make sure as you work through these couple of formulas you got to remember. Remember the circumference formula is equal to 2 pi r. And if we're talking about a portion of the circle, we've got to set what that proportion is. If it's 100 degrees of the 360, then we set that up. The other formula was when we have the formula in radian measurement. Remember the arc length, which is S, is equal to the angle measurement times the radius amount. Just to be careful, make sure that you are measuring in the right manner. If you're dealing with radians, make sure that you are not trying to do a degree solving. All right, good luck on your Delta Math.